Blockchain.
Nice. Cool, cool, cool. All right.
Okay, now you can record.
Cool. Yeah. So thanks everyone for turning up. Um, so yeah, if you weren't around last time, so this series is basically looking at kind of coding in the blockchain. So it can be a few things. Last month was around how you like what is the blockchain? What is Bitcoin? What is Ethereum? How can you interact with the the blockchain through Python? So you can look through session one again. And yeah, Pokey put up the video. So this session we're going to look more at the actual smart contracts. Because it's kind of nice reading a blockchain, but you want to do stuff. And so I think one of the cool ways to start is to look at one very common smart contract, which is the ERC20, uh, which most of us will know as basically the Ethereum standard for tokens or fungible tokens. Um, so before I go through this, like the Ethereum docs, they have a really good intro to what ERC20 is. But there's nothing new really. It's just that ERC20 is, I think it was around from 2015. 2015. It is a certain, it is a what they call an API. So it specifies a certain number of functions that you need to put into a contract for the Ethereum blockchain to recognize it as a token. And these guys are those. So um, basically, the ERC20 standard says if you have a contract, you have a token contract, you must implement all these guys here. And they look kind of straightforward, right? So it's just information around token supply, and also functions to transfer and approve, and some allowances, some events, sorry. Um, so you can read more about it here. Um, I'm gonna today look at a few different things. So as a quick intro, so we're gonna talk a little bit about um, the actual like what you need on your machine to do all this work. So what do you need to install? What do you need to have running on your machine to write a contract, test it, and to compile it, and then to deploy it onto testnet, and then eventually mainnet. And then once we go through that, we're going to look a little bit more into exactly what the smart contract is, um, and how you write contracts and how it works in practice. And we're going to look a lot at Open Zeppelin. So Open Zeppelin are a company. They're actually a company, but they've been one of the big contributors to the Ethereum ecosystem. So they do a lot of work with the Ethereum Foundation. Um, so there's a quick blurb on them. So basically, um, they work with the Ethereum Foundation basically. So some of the ERCs were proposed by them, or they have a lot of code around each of the different contract types. So we'll go through that. I'll go through all the different things that they provide us. Um, okay, but I'll start off with a run through of what we need to do. So you can read this on the GitHub. Everything's here. I just want to point out a few things. So um, obviously you're gonna need an account on MetaMask because if you want to do anything with the blockchain, you have to have an account and you need to have some ETH, right? So because we're going to be deploying stuff, and deploying requires gas. Um, Now, one thing to bear in mind is that we're going to look a lot at using um, Node.js, or in particular NPM, which is kind of the Node package manager. NPM is really useful. It's a very quick way of downloading dependencies onto your hard drive. Um, but the way that's set up means that you need to put your private key into a file. So obviously, don't do this with a wallet that you have stuff in. Normally, you would create a new wallet. um, just for deployment. Um, there's a whole topic around security and access for contracts, which we'll go through later on. So don't be afraid that if you deploy a contract using this hot wallet, you can be vulnerable because you can always transfer ownership to a hard wallet later on or like a Gnosis wallet. Okay, so I'm going to switch over to if we look at the files here, what you're going to once you git clone this code into your local machine, you're going to see you won't see all of these files. So in the beginning, what you're going to see is on the left here. So there'll be three files: the package.json, the hard hat config. You're going to see the scripts, and you're going to see contracts. Um, so to get from here to here, there's a few simple steps to do. So the first thing we want to do is we want to open up the git bash. The git bash is the easiest way to do it. So I recommend you try it this way. So with the git bash, we're going to start running some commands. Now I've got it running already, but what you would do is the first thing you would run npm install. And what this does is this goes to the package.json file here. And let's open it up. So this file basically says, in this Git repo, we're going to need a number of dependencies, the dependent third-party, packages. So you can see we've got, Open Zeppelin here because we're going to use that a lot. The hard hat also has two packages that help you with deploying and then verifying the contract. We'll use those later on. And then it has some information around certain version numbers. But don't worry about this. So this is going to tell npm install what to do. So this won't do anything because I've already got it installed. But on your side, you'll see that it starts to install the packages. So we're good. So after you run this command, you're going to find more of these guys here. Yeah. So there's some info here. If you don't have Node.js, if you don't already have Node.js, it's pretty quick.
Really weird.
Can you hear me?
Sorry, yeah.
Okay. Yeah. So that's quite straightforward. And what else? Okay. So having run this command, you're gonna have most of these files. This one you need to make yourself. The reason is this is the file you're gonna put your private key in. So in this file, you're gonna have this is a text file. Just paste this in. You will need your private key here, and you'll need API keys for Alchemy and Etherscan. Now, if you go back to my notes from session 1, if you weren't around for that, no worries. It's quite simple. There are some links here. So if you want to get an Etherscan API account or Alchemy, just follow these guys, and you'll be good. Okay, so at this point we've got dependencies. We've got the .m5 file. What else do we need? So let's go back to yep. Okay. So at this point, we can start looking a little bit at the actual contract itself. Just some admin, so you can download the VS Code. VS Code is really cool. It's free, and it has lots of extensions. So in this case, what we will do is you'll go to the extensions tab and you'll install this guy Juan Solidity. So that is a very commonly used Solidity add-in. So think of VS Code as a very general way of writing code. But you're gonna download packages. If you're gonna do Java, you download the Java package. Solidity, we're gonna use this guy. Um, and uh, so I use VS Code. We're gonna use it to look at all of these files. Just because it's kind of easier. Um, so you got VS Code, so that's good. So we can do a few things now. We can actually look at the token. Okay, so I call this whips because the long sleeves wanted me to use whips as an example. Um, so that's what I did. Um, and the first thing you're kind of gonna wonder is why is it so short? There's hardly anything here, right? So that's it's kind of one of the reasons why um, Open Zeppelin have done kind of been really helpful is that they actually have written a whole bunch of um, solidity contracts, kind of I guess you can call them example contracts. And because of the way that with if you write code, you know that you can inherit from um, you can inherit existing packages. So actually, what you find is that if you want to write Solidity code, often there's a lot of stuff already out there that you can just use. Because they're so widely used, you're going to see these guys used a lot in whenever you look at Solidity code. They're kind of very commonly used. I think that I'd say that they're almost like the golden standard for the ERC20 base contracts. Um, so be that as it may, there's still some stuff to unpack here. Uh, so what I'm going to do now, I'm going to go over to their docs, because you can see that they have kind of information on every single, well, not every single, all the different token standards that are around. They will basically support. Um, so obviously this is one of the earlier ones. So they kind of explain what's going on. They talk a little bit about what it means. So and they kind of at the end they say that they kind of introduce the idea that they have all these package contracts. So okay, I'm going to talk quickly about what all this stuff means, and then I'll show you the Open Zeppelin package uh, folder. Okay, so for those of you who've have coding experience, Solidity is a little bit like JavaScript in the syntax. But obviously the concepts that we're coding up are blockchain concepts. So the underlying virtual machine is a bit different because it's the here we're looking at the EVM, the Ethereum virtual machine. Um, but the basic idea is that like with any code, you have your import and then you have your contract here. And we want to use one of these Open Zeppelin kind of pre-packaged contracts. They call it the Minter Pauser upgradable, which is a bit of a mouthful. But what it basically means is that this is not the same thing, but it's the basic idea. So the Minter Pauser is if we look at the code. Actually, let's look at the code in here because we have it here. So the nice thing again about npm is that once you have these things downloaded, you can just go into the folder where it's pulled down, and then you can see everything here. So we're using the upgradable token 20 presets. This guy. It's right here. So this looks more involved, right? So this is basically we are inheriting all of this stuff for free. So whenever we do an import, um, we are basically taking all this code and we're just customizing it how we need. Um, But the main idea of this particular contract is that it's the base ERC20 with upgrades. What that means is that if you were around for the last session, you remember that um, contracts on Ethereum are immutable, which means that once you upload it, it can't be changed. Um, Partly due to the nature of the blockchain. Once a block is finalized, it's finalized, right? And that goes, and for Ethereum, that also goes for data and contracts. Um, but from a software engineering point of view, we kind of want to be able to upgrade contracts because there may be a bug or there might be features we want to, features we want to kind of add. Um, so, um, so how do we do it? So the idea basically that we use in Ethereum is called the delegate pattern or the proxy pattern. Um, Now it's not too difficult to get your head around, and actually they have a whole section around this. So I'll drop a link. I'll put a link into my. What did I already put? Yeah, there's already a link here. If you're interested in what it means, it basically describes why we want upgradability, how it works. The main idea is that you have two contracts. You have the proxy, which is kind of the front end, the interface for everyone to use, and then that points to the implementation contract, um, and that link can be changed. So you can think of it as an interface, and then the logic. So you can upload new versions of the logic of the blockchain, and basically the proxy will point to the latest version. Um, there are some kind of caveats, but the nice thing about Open Zeppelin is that they've also provided some really cool ways, um, easy ways to write upgradable contracts without thinking about it too much. Um, and that becomes more clear later on when we start to see how to deploy onto the blockchain itself. Let me just pause briefly to see if anyone has any questions. Okay, cool, all good. Um, okay, so we mentioned that this is an upgradable contract, and in practice, what that basically means is that you'll see an initialize rather than a constructor. You can read more about what that means, but basically, initialize is kind of where is initialize? It's here, and we'll see it here as well. So this, if you see initialize, you know typically it's an upgradable contract. Whereas if it's not, you'll see constructor. Um, so yeah, that's that. And then then we can see that it's minter, pauser, upgradable. So upgradable, which we've just talked about. Burnable and the minter is basically, it's just simply the idea that we have a minter role. So this kind of goes into the mechanics of how you supply your token. Um, so in this case, we have a token. It's just called whips. Um, there's nothing else here. So there's no initial supply or anything like that. There's no hard cap as well. In this version of the contract, which is quite simple, the owner, who is by default given the minter role, can mint as much as they want. So they can call mint, over and over and over again. They can, by the way, delegate the minter role to someone else, but that's not very important. Um, but it's nice having a different roles so that you can delegate functions to other people. And the pausable just means that it can be paused. So when the contract is paused, um, any transfer is disabled, so people can't transfer anything. Yeah, that's kind of it really. So you can see that you can. There's quite a powerful way to write contracts that are very short, using the pre-canned Open Zeppelin contracts. As we go through the series of talks, we can probably develop that more. We can add more features. Because Longsleeves was talking about how can we define the supply mechanics. So we want to be able to, maybe because he wants to maybe have a way to redeem wild for whips, so that people can, if they're playing poker, they can buy in with a certain amount, get these whips, play the game, and then um, the winner can come back and redeem for wild, or that kind of stuff. And it's an interesting question because for kind of as you can kind of imagine for ERC20 tokens, the contract itself doesn't really say anything about the default contract has minting. There's no concept of maximum supply as it is. Nor is there a concept around what kind of price do you buy. Um, so typically for supply, what you see is that there might be a separate contract. So let's say it's an ICO and someone wants to do an ICO of the tokens. So this contract is just the token itself. It doesn't really have knowledge about price or anything like that. You have an ICO contract which would hook up to a website. People would connect and then they would pay ETH or pay Tether and then get these tokens back. And then once it's ICO'd, then you would put it probably you would probably put it on a DEX with an LP. So the project will supply tokens and then Tether or tokens and ETH. And then through the market dynamics, buy and sell, the price would trend to the market. But today we're just kind of focusing on just the ERC20 token contract itself. Okay. So anything else to talk about? I think that's it. So we've looked at Solidity, we looked at the code itself, we looked a little bit at the Open Zeppelin docs, and you can I recommend you read through all this stuff. It's quite cool, especially there's a lot of practical stuff around how to write contracts. Oh, here it is. Um, and there's detail. You don't need to understand all of it, but there's kind of interesting information around how the whole thing is designed. Yeah. Okay, so that's all good. So we have now in our kind of workspace we have the contract, we have all dependencies, we have uh, your end file. Let me just talk quickly about the next two things, which is the config and the script. Um, so I didn't mention this earlier, but we're using Hardhat, and Hardhat is it's a command line based Ethereum environment. So think of Hardhat as kind of a way to compile, test, and deploy smart contracts. I mean, you can do it other ways. There are other IDEs available, but Hardhat is quite commonly used. And it's quite powerful. Um, and what we're gonna do is, so we're gonna look at so Hardhat needs some config, but this basically is kind of what you'd expect. So the Hardhat config, has some information around what requirements we need. So we would definitely need these plugins to work, which is fair enough. We also we're going to load in some of our keys from this .m file, which we've already put. And then this block kind of just tells Hardhat what are the networks we're using. So you can see we have both mainnet and Go Early testnet. Um, so here, basically, what you're doing is, um, if you remember from last month, if we need to interact with the blockchain, we need one of two things. Either you need to run a node on your machine, or you can use an API, a third party like Alchemy or Infura, and they will allow you to interact with the blockchain through their nodes. You get free accounts, but you might need to pay for more advanced features or more throughput, that kind of stuff. But for us, we just need a free account. So yeah, as I mentioned, you can get the key from the website linked in my GitHub. So this is then called to Hardhat. Okay. These are the endpoints, the URLs. basically the RPC endpoints that we're going to need to interact, to read and write, um, and this is our private key. So because we're changing the state of the blockchain, we need to be able to create transactions. So that means you need public and private key pairs. Um, Now we're not going to look at this until probably next week, next month. Um, when so next later on I'll show in Python the exact mechanics of how you transact, how you create and then sign a transaction before putting it into Alchemy. But here we don't need Hard Hat will manage all that for us. Um, okay, so that's the Hard Hat config, and then we have finally the script which deploys the contract. Um, so this is JavaScript. Um, this code is quite commonly found. Um, so if you're for example if you've built like an NFT contract, you probably use the same thing. Or if you've built your own NFT contract, you probably have used Hard Hat or something like this to deploy. But the basic idea is that we have basically, so you remember we have the Ethers plugin. So this kind of will read the contract we have, and then it's going to. So it's normally you would be able to just deploy it. Here, what we're doing is, because you remember that we're using upgradable contracts. And I told you that there's a really elegant way that the proxy is handled, and actually it's just one line here. Because actually Open Zeppelin's um, upgrades plugin will actually help you to not only deploy your contract, but it even handles the proxy for you. Um, Actually, I'm going to show you the docs for this because it's quite cool. It saves you a lot of time. You don't have to worry about your own proxies and all that. Where are we? Yeah, here we go. So this is this is talking about the not talking about the contract. Now, where's the deploy? Yeah. So we saw right the upgrades plugin. So this is a plugin that Opus have built themselves, and this actually handles the proxy behind the scenes. Um, Now there's some information around what exactly it does. Basically, the idea is that it manages for you. What does it say? Where is it? Here we go. Blah 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 blah. Yeah. So all these steps are kind of things that you would have to do manually, but it does for you. Um, so if you remember that we have two deployments, the proxy and then the code itself. So I'll show you an Etherscan shortly, but basically this is what we've written here. So this is the actual logic code. And we have also the proxy contract, which allows us to upgrade the, the implementation contract later on. But basically the upgrades this plugin does everything for you. It checks that it's upgrade safe. So there's kind of various compiler checks being to do to check that the code works. It even checks the old one. So any previous versions that you already have. It checks if you've already got this guy, and then it does it for you. So it's really seamless. Yeah. So the key is that the plugin keeps track of what you've done. So later on, we're going to deploy contracts. It's going to remember what you've done. So the next time if you upgrade it, it already has the information in the folder here. Yeah. Okay, so that's cool. You can look at this guy later on if you're interested. So first of all we need to compile our contract. So what you'll do is you will use npx hard hat compile. So this command says I want hard hat to compile the contract in my contracts folder. Okay, so we're good. Now we can run our deploy. script. So you'll see that, we'll see that this points to that file we just looked at, the deploy.js here. So basically, it runs this function, right? And you'll see this text later on, but basically, the main, the key bits are those two lines here. So, yeah. Any questions, by the way, for anyone? Okay, cool. Okay, so that's done. Now I put a note in the README, so you have to bear in mind that the contract, the message here is the proxy. So when later on we're going to verify on Etherscan. So there's a bit of a caveat here. So you got to bear in mind that this is the proxy contract. But so what you would normally do is let's just copy this guy. Now you can either look up the contract directly, or you can go to your MetaMask as well. So I'll show you this way. So so what is it? So this is an address. Okay, let's go through. Oh, okay, it's not verified yet. Let me go through the MetaMask. So yeah, this is obviously on testnet. Um, hmm, okay, what does this do? So this created a contract here. Okay, I think I know what's going on. Okay. So the reason it's done something odd is that. Oh no. Okay, it's the proxy. So this is the proxy contract. I suspect that the reason we're not seeing the second contract is that I did it earlier on in the day. Let me just double check. Okay, so I think there's already okay. So earlier on this morning I tried it. So I earlier in the morning, or early yesterday, we had normally you would see a pair of transactions. So one is the proxy and one is the implementation contract. Um, so let's look at the ones from this morning. This is the this is the so this is our code. This is the actual implementation contract. So you'll see that this is what we looked at earlier in our VS Code. Um, you'll see other stuff as well, because um, every single dependent contract is also pulled in. So so we use the preset rinse pause upgradable. So you'll see that here. Here it is. But you also see that it also pulls in a whole bunch of stuff here, right? So everything will turn up. That's why you see a lot of stuff here. Now the key thing is that we have also the proxy contract here. And the proxy contract. So here the reason that we know is because it has as proxy basically. And actually, if you go through the steps, and so when you do this, for the first time, what happened is that you won't have these tabs. What it will say instead is that you have a tab saying, is this a proxy or not? But Ethernet is pretty smart in that it can figure out what the right contract is. Um, where are we? So if you look here, this contract is pointing to this guy here, so it's the same thing. So what it means is that um, aside from the actual proxy itself, which we don't really need, what we actually want is we want to be able to call all of the token functions here. So do you remember right at the beginning I said what is the RC20? It's basically a bunch of functions, right? These guys here. And because we don't have to write out all this stuff, we're just importing the Open Zeppelin version. We don't see that in our code, but what you will do is you'll see all of that stuff when the actual contract is deployed. Um, with some extras. So you remember that we talked about having roles, and now these are set to the owner by default. Um, but you can actually set roles later on. Grant role. Yeah. So basically, once you've run this guy here, um, your work is kind of done in the sense that the contracts are there. They've been deployed. So there's one more step that you can do, which is to verify on Etherscan. So you can see that here that all the code is already here. The source code has been verified. Now the reason that it is verified is because we are gonna do that. So we're going to call this function here. So what this does is this is actually an Etherscan plugin. Um, it takes your source code from your contracts and any dependencies, and then it verifies directly with the Etherscan API, which is why we need the API key. So you can do it yourself, but it is a bit painful if you have multiple. Um, well, I found it painful if you have multiple versions. Um, uh, yeah. So once it's verified, you have kind of, and one of the reasons we want to verify is that um, it kind of once the contract is verified, you can then interact with it using these guys. Now, in our case, we don't want to do that because we want to use the proxy contract to do everything. But if you weren't using a proxy, you'll be able to see the functions. So I just want to do one more thing, which is I'm gonna just mint some tokens. I did it earlier this morning. I'll do it again. Um, so the easiest way of doing this is just to do it in Etherscan. You can do it in Python or JavaScript. And if you were to if you were to to do a website or whatever, you would have JavaScript in the website which interacts with the contract. But for testing and just for trying things out, it's fine to use Etherscan itself. So we want to connect firstly MetaMask. I think it's already done, right? Yeah. And we're going to mint some tokens to ourselves, I guess. Um, let's mint 1,000 tokens. And then, as you'd expect, you get this pop up here. So just one handy thing. So we don't MetaMask doesn't have by default a simulate. But one thing it does do is that if you try to interact with the contract in a weird way, you get an error saying I cannot estimate gas. So that will be a warning to you that you can't that this will not succeed basically. Because the gas estimation simulates through the whole thing, and if it comes across an error, it will say cannot estimate gas. Typically, it's because if you're trying to run a function which is an admin, and you're not an admin, or basically, it's kind of like a, it's kind of like a proxy simulation. Anyway, so let's just go through this guy. Um, let's see how fast Goerli is today. cool. Nice and quick. Give it a minute. Give it a few seconds. Cool. So it's done. Um, and hopefully we can see. Can we see? Can I import? Yeah, let me import. Okay, so let me just show you an Etherscan. But we'll see that we have 0 whips. Oh, that's weird. Oh, I know. Ugh, okay, yeah, okay. This is a classic mistake. Which is that um, when you so you have to use decimals basically. So basically, if so, the number you input is in way basically. Um, so you need to multiply by. So okay, so let's try it again. Let's try it again. Where are we? Yeah. Um, so 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 you know how with Ethereum you have different units. You have Gwei, which is gigaway, and you have Wei, which is basically 10 to the 9. So um, whenever you interact with the contract, you always give the amount in Wei. The reason we do that is because Ethereum EVM doesn't support decimal places, as in you can't say I want 0. 0.5 ETH. Well, you can, but you can't say that to the contract. So the way they get around it is by saying we define one to be the smallest unit, which is 1/10 to the 9. So then if you want one ETH, it's 10 to the 9. If you want half an ETH, it's 5 times 10 to the 8. It's kind of like padding basically. But what we should hopefully see now is something more reasonable. Getting closer, getting closer. What do we have? Okay, so you can see how I got slightly more this time than last time. And you can actually, so one thing you can do is, what is the contract here? So you'll notice that Etherscan has figured out that this is a WIPS ERC token. So you can actually copy the contract here and add it to a MetaMask. So let's just do that. So yeah, so WIPS 18, and then you see it there. So this is obviously this is testnet, but if you do it on mainnet, this is what you do as well. Okay, so where are we? So we've minted tokens. Is there anything else? I think that's kind of it for today. Is there any questions or anything you want to see, extra?
ATH is Wingman.
Hey,
I was just kind of thinking after you're done with making it on the testnet, is there a way to move over to the main net, like without messing anything up? Like, is there a quick way to do that, like a copy paste kind of thing, or?
yeah. So there is a pretty easy way. Do you remember? So earlier on, we configured both. So we have mainnet and testnet. And what we said is the default go early, but when we deployed, we put here network go early. So if you don't want to deploy it to mainnet, you just need to do the same thing. But you would put Ethereum. Now this won't work because I don't have any. This wallet is only has go early in it. So if I try this, it will say out of gas or whatever. But yeah, so that is a kind of the quick way you do to switch. So see, can't balance 0. So it's gonna say
Gotcha.
just
Yeah, you just have
yeah.
to have some ETH in there.
exactly, yeah. But if you had Ethernet, then yeah, then it's the same idea. So we'll put it onto mainnet, and then everything else is the same. Yeah.
Cool. Hey, I have a question.
Hey.
And this may be outside the scope of this presentation, and it's a bit beyond coding, but I'm just wondering, like, if we were to, if someone like myself was to implement an ERC20 token on the blockchain in public, what are all the legal and geopolitical implications of that? You know what I mean? With the SEC and all this.
Yeah, it's a good point. Um, so the way that the Ethereum Foundation tries to so okay, if we go to the Ethereum Foundation and what they write, so they put right at the beginning, they say tokens can be anything. So they can be points, they can be skills. So I think this is their way of saying um their way of saying that this is not necessarily like a monetary thing.
Right.
Um, so I guess the way I look at it is so a token can be, yeah, like it can be, you can say it's, the contract itself. So if we have a contract here, it doesn't really say a lot about what it does. It just says that the name is whips and that you can mint some and you can pour some. There's no, at this point there's no monetary value. And I guess if you you so if I was, if I was Gary Gensler, I'd be applying the Howey test, and the Howey test kind of says stuff like, is that do you expect a return and stuff like that. So
Right.
I think, yeah. So when you start to think about things like, so if you were to list it, or if you were to, even if you were to put it on a DEX with a liquidity pair, or obviously if you were to offer it as an ICO, so that's when you got to think more carefully about what is the legality of it.
I see.
Mm,
That makes sense.
yeah, but it's an interesting question um, because well, yeah. So there's so much else around the contract that defines the use case, I guess. So the contract itself is, I guess, think of it as the part of kind of the infra basically to what the token is. But there will be other points around how you supply, how you can buy or exchange it.
Right.
That's where then you get the bigger picture of what the value is. Yeah.
Great insight. Yeah, thanks.
Yeah, no worries. Um, yeah, so I guess I can just talk quickly about. I mean, I haven't really exactly figured out what the next session will be. I think so. Long sleeves is kind of happy to maybe figure out what we can do to run the supply. How we can mint or redeem. So if we don't have any stress, if definitely let me know if you have any interest in things. But if not, I'll kind of expand this contract. Maybe do another one, or maybe I'll add redeem functions inside here to, and then we can look at how we can do that, how test it out, and that kind of stuff. Um, yeah, but yeah, let me know if you have any suggestions or topics you want to go through. Cool. Yeah. So thanks for turning up, everyone. Hope you found it useful. So the GitHub is there in the chat. Clone it, have a go, see how you feel. Let me know if any questions.
Thank you so much, TDH. That was amazing. You're such a wizard.
No worries, no worries.
Yeah,
Yeah.
look now with loads of questions.
Yeah,
Yeah,
that's